All right, welcome everybody. Today we have MSYooper on. Uh, going to do a talk on API security. MSYooper, feel free to kick it off.
It sounds good. Hey everybody. I hope everybody's doing well and everybody can hear me okay and see my screen. But my name is MSYooper. You can call me Ben. You can call me MSYooper. You can get brownie points if you say my last name correctly the first time. But today I'm gonna hopefully brighten your mood by telling you about API security. So APIs, something that not a lot of people understand, but there's something that is going to be a real pain point among leading organizations. So if you're a developer, should you care about APIs? I personally think you should. So we're gonna kind of walk through what APIs are, and let's get into it. So yeah, we'll start off talking a little bit about me and my experience, how I got into API security to start with. But once we're done with that, then we're gonna kind of dive into, I guess, the theory of APIs. A lot of people that I've talked to and just my experience in cybersecurity want to be pen testers right away. Like they just want to break things and be, the exploit gods. But if you don't understand how something works or the theory behind it, I feel like you're kind of at a disadvantage. So I'd like to at least introduce a little bit of background to you, and then you can take that with you as you continue on. But once you have that understanding of APIs, you can move into the different attacker behaviors for APIs. So tactics, techniques, what attackers are looking for in this new API space. And then once we have covered all of that, I've got some recommendations to really talk about how you can put API security into practice. So if you're a developer or a security analyst, how you can make a difference with API security. And then the last little bit I'm really excited about is a little demo that I put together. I have it recorded as it's working. I hope it works live, but if it doesn't, it really just walks through some of the attack methodologies that we talk about here that are important with APIs. So yeah, so just a quick little slide about who am I. So if you want to know how MSYooper came to be, I grew up in Michigan in the Upper Peninsula. We call everybody that lives north of the Mackinac Bridge Yoopers, and everybody below the bridge is trolls. So little fun fact for your day, I guess. But I grew up around computers. I've been IT enthusiast since as long as I can remember, playing computer games with my dad. Um, and then I actually took apart my family's computer at one point. I don't know how far I got, but everybody tells me I did, and I put it back together by myself. So um, that's kind of how I got my start in IT. But as I got older, I actually went to school for computer science. So I went to Michigan State. So MSU, pair that with Yoopers. MSYooper was a good fit, I guess, for a pseudonym. Um, but I've worked in several different fields in IT now over the past 5 years since I graduated. So, network engineer, I really love the idea of programming routers and switches. Network security engineer, I really love the idea of breaking all of that and figuring out how to harden it and make sure nobody else can break it. And really focused on like the network communication side of IT. And then now I'm more focused on just the broad engineering spectrum. So I've been an API security engineer since 2022, but before that, I was doing identity management. Before that, I was doing security operations, working in a SOC as a SOC analyst. So I've got a whole laundry list of like 1 inch deep experience and everything, and it's all just super interesting, and that's what I love about security. So I hope that continues through my career, but it's just a list of some of the different industries I've worked at as well. And they all do IT differently. So if you're curious about doing IT, in any one of these, feel free to reach out, and I can kind of give you what I've experienced with them. So, but that's just a little bit about me. So let's get into kind of what this talk is about. So the big question, I guess, to ask yourself is securing APIs really important? Um, And this is just a list of articles from just this year of API breaches or misconfigurations that have caused headache to at least developers, but mostly security folks too. Like I said, this is a huge new area that a lot of people don't really understand with APIs, specifically web APIs and public facing information. A lot of organizations just kind of take it and run with it. So um, it's something that I am passionate about. So I figured I'd like to bring it to everybody's attention and talk about it. Um, so with that information, I just have a little disclaimer before we start talking about the specifics. So I'll be transparent with you. I do work for an API security vendor that sells an API security product, but I'm not here to sell you on any product or anything from my employer, and none of the opinions that I'm going to give you are from them. So they're specifically my own and my 2 years of experience with API security. And then the demo at the end, just want to emphasize, if you want to build your own home lab and build an API and build all of that stuff yourself to expose it and test this stuff, go nuts. But if you're going to consider attacking an actual entity or company, you must get permission from them. And, not after the fact, always do it before um, you do anything. So anyway, let's kind of dive into the theory. And if something doesn't make sense, feel free to stop me, ask a question. I want to try to keep things moving so we can get to the demo and not take up too much time. But if something doesn't make sense, just let me know. So let's start with what is an API. What the heck is an API? Because everybody has their own definition for it. And if you Google API definition, they give you this neat little snippet that's super broad and covers a lot of different areas, but it actually doesn't cover web APIs at all. So it says computer programs or components, and I think it's talking about Windows APIs, which are important, but web APIs are a totally different thing. So the way that I like to think about it is kind of this analogy where back in the day, you had software that you would buy from a big box store. You would buy like install disks or floppy disks if you're back that far with a product key that you could install on an unlimited number or limited number of devices. But you owned that software. And if you wanted to upgrade to the newest version that had all the latest and greatest features, you had to buy a new version of that software. So, that's more money on top of upgrading, on top of versioning, on top of installing it. Just a lot of time, a lot of management, but those days have kind of shifted towards more of a service model recently. So you think about services, think about, always online, always active services like Netflix or AWS cloud providers that you don't buy them unless you have a really big pocketbook, but you still don't actually buy their software, you use it. And the difference there is you're not really in charge of maintaining it. You're just using their software. So all of their versioning, all of their maintenance, security patches, that's all on the provider to essentially provide for the service users. And so when you think about services versus software, it makes APIs a little more easier to understand. And I kind of get into this here where I'm talking about um, we have so many services nowadays. Like I can't even count how many that we use at least I can't count how many I use every day. All the services that we would typically use on our phones are talking to other services that might run on servers, are talking to other services that might be actually hosting other services. And so you have this huge cornucopia, this ecosystem of services talking to other services. And it makes you stop to think, how does all of this talk to each other? Like being from network security, like how does all this talk to each other? And basically the way it talks to each other is APIs. So APIs are the language of services, how they talk to each other and how you talk to them also. Like it's not just between services. You also use APIs. So APIs have pre-existing connections. So because they're part of that service, the providers, the service providers build these APIs behind the scenes so that when you actually use the service, you don't have to do any building work on your end. You might have to authenticate every so often for a session, but essentially, you're using the service to communicate with it and get some value out of it. And so the provider is responsible for getting all that working. So APIs are just part of that service that they provide, and it's good for you because it makes it much easier to use these services. And if you're in this call right now, you're using Discord. If you're in any sort of audiobook land or music land, you're probably using Spotify or something like it. If you're traveling anywhere, you're probably using some map application. But all of this ties together in saying that all of these services have APIs available. So if you're in Discord, I actually have a Stream Deck that allows me to control a bunch of aspects of my content creation or my streaming. And I can actually build an app within Discord to handle those API calls between my Steam Deck or whatever software I'm using and Discord. And same thing with Spotify. You can get a bunch of information from them for whatever purpose, whether it's a personal site or some folder. I'm not sure, but Google Maps, if you're building like mobile applications or a website that uses points of interest, you can use Places to build out all of those libraries, so you don't have to build them out yourself. So just to throw some numbers at you, just to kind of wrap your head around how big APIs have gotten over the past couple of years. 83%. So I pulled these numbers from a couple different sources, but 83% of the total internet traffic today is using APIs. So when you think about all of the, what are we at now, zettabytes of information that traverse the internet every day, 83% of that using some sort of API service to service language is it's astounding. And 100 plus the average number of APIs managed per organization. So, we'll talk a little bit about what's actually in an API and how you communicate with them. But, 100 might not seem like a lot right now. But, even just thinking about like a small startup bank or something that has over 10 or 20 APIs that they have to manage completely, it's a lot. And once we talk a little bit more about what's in an API, it'll make more sense. But that's a pretty large number, and 10 million is just an astounding amount of requests that get received per month. So every single one of the APIs within an organization, you're looking at hundreds of thousands of requests per day, per week. So APIs have, they have not shrunk in the past couple of years. They're continuing to grow, and the popularity and the footprint of companies is growing as well. So with all that said, I want to try to get into a little bit more about what APIs are in terms of like classifications and their protocols. So within the world of APIs, you've actually got a few different types of APIs. So if you're familiar with public APIs, like Discord's public API or Spotify, these are APIs that are available for anyone to use on the public internet. Um, and companies might, have a huge footprint of public APIs. They might have a smaller amount. They might have more internal within their company. They might have strategic business cloud provider APIs that communicate directly with, AWS or Google Cloud. So there's a bunch of different types of APIs, and I'll kind of mention later on about why that's important, because a lot of times a lot of focus gets devoted to one type instead of all of them. But within APIs and basically like how you communicate with APIs and endpoints, you have a few different protocols and methodologies, many more than I have listed on this slide. But one that we had talked about before the call started was REST, and most of the time that's the go-to protocol or methodology. It's not technically a protocol, but it's the easiest to kind of wrap your head around the idea of communication with APIs and just web communication in general. Um, you can definitely research more on these other protocols and types, but kind of following that idea of REST APIs. So, one thing to keep in mind with APIs is that they can be stateful or stateless. So, the idea of that is you may or may not be uh, tracking previous parameters through requests. So, REST APIs, like if you've seen most commonly, they're stateless. They include every parameter with every request. So you have to submit every single parameter every single time in order for that to be accepted in a session, just because it's not keeping track of your session. But stateful REST APIs may track your current session based on, API tokens or session cookies, or, it's one is definitely better. I don't want to say one is definitely better than the other, but just to keep in mind, there are REST-less APIs and RESTful APIs. So depending on how you're looking at uh, your how you're building APIs or how you're using them, to keep those in mind. So what exactly is in an API? So this is where that 100 number kind of balloons quite a bit. So within an API, you can have one, but usually you have hundreds of endpoints. So for each API host, you've essentially got a number of functions that an API could perform. So if you're, for example, working in a bank, you might have an API that handles deposits. You might have an endpoint that handles deposits. You might have one that handles withdrawals. You might have one that handles account lookups. And each business sector really has their own use case for what each endpoint will do. But if you've got, hundreds of endpoints that are handling deposits and hundreds of endpoints that are handling account lookups, um, your 100 APIs quickly becomes this giant monster of a footprint that, if you're not keeping track of it, it can grow out of proportion really quickly, especially if you're trying to grow a live service. So with all that said, how do we actually communicate with APIs? How do we talk to these endpoints? And essentially, we call them. So if you've ever heard of API calls, if you've ever, obviously you can go to google.com and you can check the session or the network traffic that goes through in your browser. You'll see that you make a GET request to google.com. It's the same kind of process with endpoints. So following the HTTP request methods that are out there, you have the methods that most of the time you're focused on, for all you database admins out there, the CRUD operations, so get, post, put, and delete. Um, each protocol is going to have their own set of request methods, but again, with REST uh, methodology being somewhat well known, and same thing with HTTP, it's just a well known idea to kind of get your head wrapped around this idea. So whenever you're talking to endpoints or APIs, you're calling them, you are either creating, reading, updating, or deleting information, um, as part of that function, as part of that process. And so I mentioned using like a web browser to call some of these APIs, like, just locally. But if you actually want to test uh, endpoints on a broader scale, you can use a couple free tools. These are the ones that I use every day in my job. So Burp Suite, Postman. Um, Both of them have free versions. Burp Suite definitely has a paid version. It's kind of expensive, but if you have the license for it, it really makes a difference. But Postman is free. You can download these and play around with them. And I encourage you to do it because um, learning with like by doing is how I learned all of this stuff about APIs. So Postman actually posts a bunch of API collections that are public. So if you want to learn more about how these endpoints operate and what their behavior looks like, things like responses and response codes, um, you can play around with them just within Postman, and it's really cool. So definitely check that out. So kind of talking also about response codes. So again, if you're familiar with HTTP, you've heard of response codes, HTTP 200 OKs, 404s, not founds, um, 500 server issues. These are just basically telling you as an end user, hey, this message was a success or there's a failure and where that failure lies. So there's a lot of online resources for putting these together and deciphering them. Mozilla actually has a really good website that goes through even more than just these. Like there's 100s that aren't even on this list, HTTP 300s. There's a huge amount. So you can definitely look those up if you're curious. But tying kind of back to the API talk of, services talking to other services, what does this mean for me? Um, the cool thing about with all these live services coming up and all of these integration or all of these communications happening is that we have integrations. So if you use Spotify like I do, and you perhaps log in with a social media account like Facebook or Google or I don't know what other ones they allow you to do that with, but um, you can see what your friends in Facebook are listening to. You can see what their listen time is, and you could even start a jam with them. If anybody's actually done that, I don't even know if anybody's actually done that, but um, it's a neat little feature that they put together in collaboration with Facebook's
Awesome.
service. Okay, cool. Um, and then within Facebook, you actually have the ability to stream full Spotify libraries from Facebook's app. You don't even have to leave. Actually, I don't know if you can stream full libraries, but you can stream songs that get shared to Facebook. So you don't have to like leave Facebook to go to Spotify. Just listen to it in your Facebook app or your browser or Google app, whatever. Um, so it's really cool. Like these providers that have all of these integrations set up behind the scenes just make it easier for you to use their service. Um, which kind of leads me into the whole point of this talk. So why would we secure, like, what the heck is API security? How does it tie into using APIs all the time? Um, and if you would have asked me what is API security when I started my job interviews, I probably would have give you at least one of these: securing your APIs, security of APIs, uh, securing securely using your APIs. A lot of broad definitions, and a lot of people will give these definitions nowadays, and they don't really have a lot of background, and it's becoming that real pain point because if we're going to secure APIs, we really need to understand what API security means. So let's try to put this more into like that service software perspective, I guess. So with this graph, I kind of am a little confused every time I look at it with the ease of exploitation. Basically, if you go up that y-axis, it actually means that it's more difficult to exploit. So a web application would be less difficult to exploit than an OS. If you're actually hacking OSs, you're probably smarter than I am, but you can actually get more capability, shocker, from uh, hacking an OS than from hacking a software application. So this has kind of been the trend for a while. This like linear uh, complexity of capability versus uh, exploitation complexity. So with the APIs introduced, though, or with service to service communication, instead of having that lineality of complexity, we now have this communication that's happening over the public internet that doesn't really take a whole lot to exploit if it's implemented poorly. And then you can actually get more capability out of hacking an API in some cases than uh, spending a lot of time looking at other possible vectors. So this is just something that, you know, attackers are taking advantage of. And you remember those handy API testing tools I told you about with Postman and Burp Suite, those, things you could play with on your own time. Um, the attackers are playing with them too and adding parameters, testing what comes back. If You say that you're an admin, but you're actually not. You give somebody else's session token, but you're not actually that person. You know, it becomes a real headache when you try to think about, okay, well, if you're an attacker and you've got this low hanging fruit of API exploitation, and you've got this tool set where basically you can just log in and launch these attacks from anywhere, what would you call this? You know, I personally call it open season because APIs are just everywhere. And with the footprint that keeps growing with companies and the amount of attackers that are realizing that, hey, these aren't implemented correctly in some cases, APIs have kind of become the Wild West where you've got all these cowboys and, you know, bandits coming to steal your data, and they don't really have to put a lot of effort into their tooling or their methodology. They just kind of have to pick and choose what they want to go after. And so, kind of to drive that point home, let's say, for example, back in the day, you wanted to track the location of a user. You know, how would you do that? You'd exploit software to track their location, and by doing that, you would go through a laundry list of requirements. So before you can even craft an exploit, you have to pick your target, and then researching their hardware habits, and then actually finding out, do you want to pick a phone or a laptop? What software do they have on those devices? And then finding vulnerabilities of that software to actually craft an exploit. But then you also have to take time to deliver it. And then you have to take time to make sure it persists and collects the information that you're looking for. And then depending on what your use case is after that, either selling that information or storing it for ransom. As an attacker, the list kind of is repeatable, and not in a good way. So if you've got multiple versions of a software that you're trying to attack, you have to craft an exploit for every single version. If you have multiple targets, you have to craft an exploit. You know, maybe you get two or three in a group if you're lucky, but most of the time, um, you're spending time researching more and more targets, and it just becomes a headache, a real time consuming thing. But we talk about services and the amount of live services, and that's increasing every day. And service users, like the number of service users, are increasing every single day as well. So, how does that same attack look from an API perspective? You basically only have three steps. If you want to target a certain person, if you're thinking about that, you might have to get a little more granular. But most of the time, because this is a low hanging fruit, an attacker is just going to take the most vulnerable thing they can find, attack it, get the information that, or the capability that they need, and there you go. Um, and this is kind of what drives the point home of API security, because a lot of the times with companies growing their live service portfolio, they're not looking at the big picture of, pushing new versions. What happens to the old version after the new version comes into play, after we migrate all the users over to version 3? What happens to version 2, or what happened to version 1? You really create what's called a zombie API, like this black box of, you know unknown, that this attacker, if they stumble upon it and see that there's no security patches or maintenance being done on it, it leaves you open to attacker opportunity. And speaking of attacker opportunity, if you have a feature that you add into your app or your website that uses an API, and that wasn't developed securely, I think one of the people I talked to said it best when they said every feature is an opportunity. So every feature for an end user is an opportunity for an attacker. So if you're not looking at your features, then you're just leaving yourself open to even more of a headache. Um, and so you think, wait, attacking got easier? I thought we were supposed to be getting more secure as time went on, but the opposite is unfortunately true here, where software exploits, expensive, time consuming. If you do get it to work, you've got a good, like, nuclear option to put in front of somebody. But most of the time, if you want to make a quick profit, um, Nowadays, attackers will just target vulnerable services. It's easy, easy in scope, easy is quick, and it's just mind blowing to see that happen in real time. So let's kind of tie it back to what is API security, and to me personally, securing APIs, yeah, it means securing your APIs, but it means a couple different things. It means being able to detect attacks on your APIs proactively. So don't be reactive. Don't wait for the alert to fire. Being able to have, a scheme that can detect these proactively. But in addition to just attacks, right? You want to be able to have that inventory of all APIs within your company or yourself, your business, as well as your endpoints. Because again, if you're growing your footprint and you're pushing new versions of APIs every day or every week with your development cycle, and you fall behind on a couple versions, those get lost in the breeze with documentation. Um, it can become unmanageable pretty quickly. And so that's just the last point too. Document everything. Documentation stinks. As somebody who's written documentation before, it's not great, but I would rather write documentation than spend 3 hours in a session trying to figure out how something works, or dig up something during an active incident. So that's just my opinion. Um, so if you're familiar with application security and application DevSecOps, you've probably heard of OWASP. We've got the group out on the West Coast locally that is affiliated and has all of this. The OWASP group actually has a list of top 10 vulnerabilities for web apps. But something I didn't know, and I'll let you know, is that they also make a top 10 for API security, and it's called the OWASP API Security Top 10. And within this list, it follows kind of that same pattern as the web app security top 10, ranking in criticality from API 1 to API 10, just the most severe and common attacks that are targeting APIs. And it's something to keep in mind. When I started my career, I was following the 2019 version. The newest version has added some new attack types in there and has combined a couple of them into new names. So I have a few slides. I want to keep us moving though, so it doesn't really cover the specifics of these top 10. But if you're interested, reach out to me. I can kind of walk you through some examples, or you can look up on OWASP's website of their definitions. They do a really good job of explaining what each attack means, and we'll actually look at one of these later in the demo. But just wanted to introduce that here. So with all that said, how can I get into a secure API mindset if I'm a developer or I'm a security analyst who might have never thought about API security before? I'm focused on security, but not API security. What can I do there? And to kind of summarize what I've talked about over the last half hour almost, DevSecOps and secure coding is vital, especially now that we're in this era of like live service deployment, where there's a new service springing up pretty much every day, and communications happening at a massive scale. So DevSecOps secure coding is important, but a lot of times security analysts are the people who will say, let's just skip the code review. Let's all, hook up a SIM, set a logging alert. We'll let you know if anything happens, all good, moving on. Being somebody who's worked in a SOC, I can guarantee you that there's more pressing alerts that'll pop through if you just have these set as low priority, or being forwarded to some, dark corner of the organization. So it doesn't really answer the big questions when it comes time. Like if you can't find those alerts or they're not providing value for APIs, it's the same idea with like network security. If you don't get alerts that can help you understand these questions of like how breaches occur, how, where the documentation is, what's the user impact, your management probably won't be happy with you. Compliance certainly isn't going to be happy with you. and you're not going to be happy digging through a data lake trying to find answers to all this stuff at 2 a.m. So um, it's kind of a no-brainer to take the security route, and then diving into how API security can actually be executed. So a couple points that I think are important for developers for just API security in general. Securing your code, writing it right the first time, and developing it with DevSecOps in mind. Um, it's going to save you headache if a breach does happen, because you can kind of track down where in your code is wrong, or you have to adjust some parameters. If you push new versions and your code is secure, then you don't really have to worry about breaches after the fact. So um, securing your code, reviewing it. So not just your code, but also your architectures, your documentation. Doing this regularly and not like every year. I would say basically every version, if you can, version update, every patch that goes through. Make sure that you at least review the code, review the documentation, make sure that that's all up to date. It'll save you a headache. And implementing access controls. A lot of times, desktop admins have been hearing this for years. Like, the main pain point of IT is the end user. So if you know anything about like end user behavior, whether it's malicious or ignorance or just curiousness, just because you think someone will use software or APIs correctly, it doesn't always mean they will. And attackers certainly won't. So making sure that that's all good and checked out before something bad happens. And then keeping track of your inventory. So documenting everything and keeping track of your inventory. I have starred here because I want to kind of reemphasize these with a couple examples. So we talked about the 100 plus APIs per company and thousands of endpoints. How would you keep all of these together so that you can actually manage them all? Would you put these in some JPEG screenshots on your desktop, or you know make a Git repo, or depending on the size of your organization or your API posture, you might have a solution that's better than the other, but there the wrong solution is no solution. So being able to have an inventory that's up to date and is actually being kept managed by somebody within the team, or single developer, making sure that that's accessible is pretty crucial. um, but how would you document everything? If you're a huge company, and you're trying to document all of these APIs and their behaviors, and you keep creating new ones, what makes the most sense to you? Again, if one makes more sense, use it. But a lot of times, you wouldn't think that this documentation stuff matters. That's just IT in general. I feel like everybody wants to be the next innovator and develop the next, you know, iPhone app or AI app. So they just keep pumping these things out and don't document anything. But what if you're an API developer for, say, a major bank, and you're pushing out these new versions of APIs where um, nothing is really being documented, and version 3 keeps everybody happy, but the SOC comes to you and says version 1 is not making us happy. It was exploited according to our alerts, our logging alerts that we set back when it was first brought online. um, Apparently data got leaked. So what can you tell us about that? You probably look at them as someone from SOC like this, like version one of what? I just spent all these coding cycles developing version 3. So kind of listening, half listening, and then just yelling, didn't we decommission this years ago? Hey, so and so. Um, and when you get that no answer, it quickly becomes that mad scramble of, what X developer did we task with writing all that documentation? Where did they store it? Um, I personally wouldn't want to be the one calling up X employees on where things were stored. So, um, how can I document APIs is really the point here of documenting APIs. It's a big task. I won't lie, and writing documentation isn't the most glamorous thing, but documentation, I kind of alluded to it before with the whole classifications of APIs and types. It's really focused on anything but public APIs because most of your user base is using public APIs. If you have internal APIs and new partner APIs that come online, it makes it a little monotonous, I guess, to have to dig all through your existing documentation to find information about that. And unfortunately, there's not really a good single formal standard for documenting every single type of API. So public API might use Swagger files, and internal APIs might be written in some like XML format. Um, so the best advice that I can give is just picking the best option for you. Again, with like documentation, inventory management, picking the best, being consistent, and then, like I said, updating regularly. Like not every year, but pretty often. Pretty often. Um, and here's just an example: Swagger inventory. If you're not familiar with Swagger, they're basically this repository that companies can implement on their own uh, in their own environments that can give you like this documentation of here's all the different endpoints, here's all the request methods that they use, and some of them might have parameters listed within them um, to kind of give more information. But okay, so we talked about what the developers can do. And so what can the security analysts do? Uh, I obviously like I don't want to rip on security analysts for using a sim because I've used them. They're great. Um, but I definitely want people to use sims for what they were designed for because a lot of times if you set alerts that don't matter, then they're just not useful at all. They're just noise to your security teams. So reviewing, configuring, and testing alerting, making sure that your architecture is configured correctly, and then, like I said, vendor solutions. If you want to get into the weeds of that, you can research it. But there are companies out there that offer solutions that are a little more granular than the traditional web app firewalls and will do a bunch of features. So if that interests you, feel free to check those out. And then the last thing I'll touch on before we get into the demo portion is how can you demo this on your own? If you've ever heard of Crappy, so it's the completely ridiculous API. It's published by OWASP. It's available on Git as a Docker image, so you can spin this up in the cloud or spin this up on your local machine, and you can play around with it. I played around with it a lot, and just kind of laughing at how badly it's put together, but that's kind of how it's meant to be. It's good for testing if there are security alerts that come through that don't provide a lot of value. You can tune up your alerting and your detection rules for both developers and security analysts. Um, and so, if you're interested in demoing what a bad API looks like, how not to write one, you can go play with Crappy. Okay, so since we've reached the demo so quickly, does anybody have any questions before we get into like the actual practical use of APIs?
I got a whole bunch of questions, but I wrote them down, so I'll save them until you're done.
Okay, then let's transition into putting all this theory into practice. So let's take, for example, a company here. We call them DLPC. So they are a computer equipment vendor. They sell laptops, servers, you name it. If it's computer equipment, they probably got it on their website. They've got resellers and partners all over the world, so they're a globally known brand. They've got billions of dollars in annual sales, and they've got a rabid customer base of millions of people that are waiting for the next big release. So everybody's following them, and with their partners and resellers, they actually have this neat little feature where if you want to become a new partner or reseller, you can submit a form on their website. And after your application is approved, you can actually get access to this neat little API function that takes different parameters and returns some interesting data based on your access. So if you're a partner or reseller, you have this whole treasure trove of information that you have access to for your business. So let's say an attacker signs up for that access on DLPC's website. Now they're not an actual partner or reseller, but they have, let's say, like 50 different company names in their head. Um, and there's no limit to the amount of times you can submit this form. So, the attacker just submits several times with different fake partner names. And, they might send one just to test it out and see what happens. Um, and their applications get reviewed by somebody or something, and they get approved. And so once you send that first application, if it does get approved, you might say, "Hey, I'm going to send it, 49 more times because obviously I'm not a real reseller. So, who's going to check and make sure that I am?" So no verification there, just their access gets approved. So now they have access to this API, and they start playing around with the parameters. So whenever you're pen testing APIs, one of the first things that most people do, or what I like to do, is just play around with the behavior, see what happens with different, you know, added headers or adjusting some body parameters, taking things out, what kind of error messages come back, things like that. But after playing around with it, the attacker finds that a 7-character alphanumeric string acts as a service tag ID. So if you are familiar with desktops, they have a service tag that you can enter into a website for the vendor that basically looks at it and says, "Hey, as opposed to like a serial number, usually they give you the option of service tag or serial number." And when you enter in a service tag or serial, they'll give you a list of options like documentation about the product, software updates, uh, installing the annoying little software that'll like update you on the newest updates or whatever. Um, but in this case, we have a 7-character string that acts as a service tag ID. And when you put this into the API that this attacker now has access to, it returns personal data from the database of DLPC. And uh, this could include anything from like credit cards to social security numbers, depending on the business case. But in this case, we've got names, addresses, delivery information, machine information. It's all pretty, relatively easy stuff to find, but it shouldn't be exposed on the public internet like this. Um, so who's to say, like, if you're an attacker, why don't you just loop through every single possible 7-character string? Um, the biggest thing you're going to run into is time, because 36 to the 7th is not a small number for all A through Z and 0 through 9 strings. So, but you have, as an attacker, like the attacker signed up for access, let's say 50 times, they've got 50 different API keys for this attack. So let's just distribute this out and allow this to run for a few weeks. Like if the access gets cut, who cares? Like we have access to this API. Let's see how much we can grab before they cut our access. At the end of the day, the attacker walks away with millions of DLPC's customers' personal data. So names, all those things we talked about, addresses. So it's a pretty good haul. So as the attacker kind of has the kindness in his heart, he reaches out to DLPC before he posts anything and says, "Hey, I have your data. I think you should probably patch this endpoint or this process." And DLPC does not respond to them initially. So that's kind of discouraging. But as the attacker who has all this personal data, the attacker might just, hold it forever, or they might just get bored and post it on the dark web. Who knows? But most of the time, that's where everybody's personal data ends up anyway. So it gets posted on the dark web, and that's kind of the end of the story. So what can we take away from this? Well, number one, I don't know who's reviewing API access for DLPC, but this process was broken from the start. There is obviously some need for documentation that had to be supplied in this process, but clearly it wasn't. So that's just an epic fail there. But if the attacker was allowed to run this attack for weeks, like think about that. If they're distributed over 50 different accounts and they're running this for several weeks, and each request or each host is probably not a supercomputer, but if they're sending hundreds and thousands of requests an hour, like wouldn't that raise an alert somewhere? Wouldn't somebody cut access to that API at some point? But they didn't. So what were they thinking? So that's kind of what I put together here. So as part of the simple architecture diagram, typically when you're working with an API or any web server, you would have this set up in this tiered architecture. I have it set up locally on my machine, this whole thing. So it's a little more simple than this, but essentially an end user communicates with proxy, right? They're not going to talk directly to a database for a company. So there's going to be some sort of handle that checks access controls and things like that. And the API that handles these calls would forward that request to the database and handle that communication where the database sends it back or sends that response back, whatever data is being acquired, and then sending that back to the user from the server. So with that said, who's to stop me from also being the attacker? So if I'm the user, I could also just be the attacker on my own machine and abuse that API and try to get that data unauthorized. So let's hop over here and let me know if my screen cuts out at all. But pull this up here. I'll make this a little bit bigger so everybody can see. So essentially what I've done is I've created a MySQL database that has a bunch of different garbage data in it. So within the database, we've got a user purchases table. So we'll just use that table. And then once we have, we'll use that database. And then within that database, we have different tables. And within this purchases table, if we do a quick select one, or we do a quick select from there, we can see kind of the schema that we're using for this data. So it's a little similar to the DLPC example. I'm only using 6 characters in my service tag just to keep things cut down a little bit. But you can see we've got names, emails. All of this was garbage data. I just asked ChatGPT to fill in to a database and gave me an insert command. So if you wanted to check how much data is actually in here, we've got 47 rows. Yeah, my SQL is not great, but it gets the job done. So I will keep that in mind. But essentially, we've got 47 rows in this database. So not 47 million, unfortunately. But if we transfer over to the application that I have, so we have the database, and I've basically configured this application, this Flask API, to handle the call from our from our end user, and then make sure everything looks good there. Okay, so this Flask API is handling a call from the end user looking to enter in that service tag that we had talked about. So I just quick built a little HTML front end for this application so that we can actually see this from the web browser perspective. But essentially, we have this query order method, this query order endpoint, that's going to take our select statement to the database and say, hey, I'm looking for this service tag. So let me quick start this up. Over here. And so, like I said, just really basic web front end. But if we wanted to query a service tag, take the one that we had before and test it out. So we get that same information we got from the database. Um, and we can test this out with the other 47 uh, service tags that are there. But if you wanted to, just throw in a bunch of garbage data, you can see that it throws back an error message. So it's a little descriptive, like tag number not found within this database. So it's not too descriptive, but because we have this error message with this output, an attacker might say, okay, well, it might not be there. So let me just try to figure, an attack out that can be destructive there. So you can see these API calls that came through, or these requests. So we were able to find one service tag okay, the other was an error. But let's try to build something out that will attack this. So this attack script does the same thing that the attacker's script does. So looping through every single 6-character string and then sending that along to that endpoint right here. So if it gets a 200 OK back, meaning that the HTTP response was okay, there is data, we can store it in a JSON format in our data frame, and then at the end of the script we can export that. Now, obviously, this is going to generate a huge number of requests. It won't be successful because I don't have that much data in it. But just to give you an idea of what this looks like, we'll run this, and you can see just how many service tags are being looped through per second. And I won't stay on this screen for too long, but there's so many API calls and requests coming in to the database to find these service tags, and they're all erroring out. So, you can look at the timestamps. I'd say 20 plus requests per second, which again, mind-boggling that nobody caught this as an error message or any sort of alert beyond just a logging alert. So with all that said, how can we combat this? We talked about kind of the OWASP API top 10 and how there are different attacks that this follows. This would be a classic example of API 4. So we are just, brute forcing using unrestricted resource consumption on this web server, basically DDoSing it, just trying to find information and distributing it over multiple accounts as the attacker did. So in order to combat that, what we can do is we can use this neat little library within Flask called Limiter. It's just a simple way to set a limit on the amount of requests that come from a remote address. You can set default limits within it, just as all methods will use that. Or you can just set them directly within the method itself. So here I'm just saying, 20 per minute. This is the amount of requests that the API will be able to process before it starts erroring out. So if we save that, it refreshes the page, and we try running the attack again. And what'll happen really quickly, if I could stop it in time, right here, you can see after it reached the 20th request, it began sending back 429 responses. So HTTP 429 is too many requests, and that's because of our rate limit function that we put in. So that's cool, but it's not a foolproof solution, because even if you implement a rate limit, an attacker can still figure out, hey, I was 20 requests in before this started airing out. So what if I, as the attacker, adjust my my rate limit? So if I am able to separate out my requests with the sleep function of waiting a second or 2 seconds between requests, odds are I'll probably be able to get through more of these. So if we do this and rate limit our own attack script, the requests come in at a slow crawl now, but you can still see they're coming through into the server. And after a while, what you'll see is it will still error out because the rate limit is still too low. But it's just this cat and mouse game between the attacker and the developers at this point of what is acceptable for a rate limit. And it's at this point that I would hope that security analysts would say, if you have a rate limit alert that's set for this API, this endpoint, you would say, this IP address is constantly hitting this rate limit. We should probably block it. Um, but unfortunately for the attacker, too, the last thing I'll say is all of these that are getting 429 responses back, these are not being checked by the server. So if there was a service tag with quadruple A, B, F value, you would never know because it wouldn't actually check that response within the database. So this is just lost forever until you can figure out how to adjust your attack script. So let's go back here. So that's basically it. Walking through that demo and kind of giving you a heads up of what that was, that attack. But I'll break the ice to you. The last thing is that this wasn't fake. This actually happened, and it happened to Dell this year. And if you want to read more about it, it's a little more technical than what I made it, but essentially, the whole concept of API access, API usage, data breach is all there, and it's really interesting stuff. I encourage you to check it out. So to wrap things up, I just want to say thanks for spending the hour with me, hearing about all this. And if you want to learn more, I highly encourage you to check out a couple of these courses that I went through as part of my API Security Engineer journey. So Port Swigger makes Burp Suite. They're the product owners of Burp Suite. They actually have an entire academy for hacking, but also defending APIs. So their web security course is really cool. I recommend checking that out. API Security University is a new one that just popped up recently on my radar. They cover a lot of the theory that we talked about, and then you can check out more of their examples that they have. And then for everybody that's getting started in cybersecurity, I can't stress, sign up for Try Hack Me. They have the free tier, but you get a lot of value out of Try Hack Me, and their rooms on the API Security Top 10 are great. They also have just web fundamentals and just learning APIs in general. So definitely check those out. And then the last thing, I know a lot of people that I've talked to have opinions about TCM, but I think that they put really good content together for APIs and web hacking in general. So a lot of the examples that they'll use reference either Try Hack Me or Port Swigger, Burp Suite, and just the practical use of those tools. So definitely check those out when you get the chance. And with that, I just want to say again, thanks for sticking around. And if you have any questions, we can discuss them. But that's basically it.
Yeah, I got some questions.
Thank you. That was awesome.
Thank you very much. Yeah, Werelock, you have questions?
Yep. I'll shoot them over right now. Put them down. So yeah, I don't know. I just kept thinking of things, and so I just sent it off to you. So you should be able to see that as a little message.
Yeah. I see it.
Yeah.
So API key storage and management. A lot of times people will use like these providers like AWS keys and storing keys. The secret management services that I'm familiar with are kind of those services. I guess what's the question around that?
So, well, I mean, I recently ran up against this, trying to develop like a Discord bot that it was bringing together multiple different API services, and in order to deal with these services, you need API keys, right? You have to
Mhm.
have one for Discord, you have to have one for Google Calendar, and you don't want that you don't want that to end up in your public source code that you posted on GitHub, right? So
Right.
if you're deploying something as a Lambda function or something that lives purely within, AWS, well, then the AWS Secrets Manager, is great because then you don't have to go through an API for your Lambda function to reference those secrets, right? But if you have it live elsewhere, I don't know, just sort of like, have you, you know, given advice about that, ran up against issues like that? Do you have like kind of a go-to
Um, I
sort of
mean,
preferred?
yeah. I mean, I'm personally like I tell everybody like I'm a API security engineer. I don't really develop APIs or like once the company has their sort of architecture for this. I don't really control what that looks like. So I don't really have any solid recommendations. But if you have something like AWS
But you,
keys that works, then
but
I definitely check it out. But
but for this stuff, I guess maybe that you're brought in to. I mean, do you advise teams where you found issues with their APIs? I mean, like you're studying all this API security, so I'm assuming that you're acting as
yeah,
some sort of a consultant fashion, right?
somewhat. So if we want to get into like what my role is, so basically I'm a API security engineer that we have our company product that handles like the inventory and inventory of APIs and the detection of attacks against those APIs. So kind of split between the inventory side and the attack detection side. So not necessarily in terms of like architecture and things
Okay,
like that.
more like
So
discover, like enumeration, discovery, that kind of stuff.
right, like if there's an attack that comes in against a particular API, there's that
Okay,
kind of stuff that I talked about. But when it comes to like actually building out what an API looks like and consulting, that's more of the sales and technical solutions architect side. So I'm not that deep into it. So
okay. And then on the second question,
API Explorer websites. Do you have an example? Not really
so one
familiar
of the
with what
things,
that
like when I
means.
used to work at Amazon, that really helped me out, right? Is that they've got, I mean, they literally have, oh my God, APIs for like everything, right? And they
Hmm.
develop a lot of internal stuff. So whereas, some random company might use Jenkins or something, and that's their, they've integrated that into their little CI/CD pipeline. Amazon writes their own, right? And
Hmm.
everything there has its own API. In fact, they actually have some sort of a common API service that if you want to build an API, you would use that. And if you do that, then it becomes trivial to spin up what's called an API Explorer website. And what's great about that is it'll list all the different calls you can do, all the different endpoint, whatever
Oh,
URL endpoints, and then you
okay.
can click on one of them, and it says, okay, well, here's a little form. You can fill it out. Similar, almost like a Postman style thing, but it's webalized. And so you can pick one and say, okay, let's say I wanted to make a call to this, and if you're maybe like it has a little form, and you fill it out of what you're looking for. It'll construct all little fields and actually call the API, and then it gives you like a curl statement underneath
Hmm.
it that if you could just copy and paste it. But in their case, they were using Kerberos authenticated curl, so it was kcurl. But you could
Okay.
literally just steal that kcurl thing, drop it in a bash script you're writing, and now you have functional access, to their API to get exactly to get that JSON blurb, output that you were looking for, and you just dump that through JQ and pick through what you want and functionally, use these APIs. So that's the
Okay.
concept of an API Explorer. But you haven't seen that in the wild?
Um, I mean, honestly, that was probably the first time I've heard of it directly called an API Explorer website. So no, I'm not very familiar with that. I'll have to look at that
Okay.
a little bit deeper because that's actually really interesting.
Yeah, it help. Yeah, when it's available, and it's not just limited to Amazon. I have used it in other contexts
Right.
as well. So yeah, it's out there.
Okay.
Okay.
Your third question, investigating, revealing undocumented APIs. So that kind of ties back to, as traffic is coming in, if things aren't decommissioned, a lot of times you might still see those, alerts come through for a security analyst team. But essentially, you have solutions out there that have the capability to basically take a copy of the traffic that your company sends to or is receiving or sending from APIs or their endpoints, and then having that solution be able to look into what is actually sending traffic. Um,
So for like
that,
actively used but like really old APIs, like that version one thing you were talking about, like
yeah,
essentially reverse engineering it from having access to traffic that you can, sniff and then feed it through some tool and go, oh, look, you guys thought this was decommissioned, but here's this one thing that's still using it. And you guys were, like in response to us, telling you, hey, this thing, holy crap, it's got problems, you should like decommission it, and they're thinking about doing it, and then they realize, oh, wait a second, these guys are using it, we can't shut that down, it's
right, yeah,
legacy, right? Like tech debt. So
right, yeah. I kind of have to stay at a high level for that because part of
okay,
our products is all of how that happens. But yeah, basically the whole idea is there are solutions out there to do that. You don't just have to like
so,
blindly throw
so that's
darts
more of
at
a
things.
That's more of like passive discovery, though. Like if you were trying to do active discovery, like if you knew that there was a version 2 or 3 or whatever the latest one is, and then you're like, okay, I want to query this on version 1, but I can't find any documentation for that, to discover what all the different calls are. If you don't have documentation, if you don't have an Explorer website, like an approach to kind of sussing those out.
Yeah, I would have to dig into that a little more because from my understanding, the services that I'm familiar with are active discovery, so they're actually looking at live traffic that come through, as
That's I,
opposed to like
okay.
there are solutions that basically do both. Like if you're looking at passive or active, depending on like what your business case is. Like some companies might not want you to have active sniffing on their network. Obviously, like sending it off of their network with sensitive data might be not great. So, um, yeah, it's kind of use case dependent of like if you're curious about your undocumented APIs, but you have compliance that you have to deal with, you might choose one or the other. But yeah,
Okay. I just wondered if there was like, from the perspective of not having access to sniff all that sniff data, and you're like, okay, well, I want to see, do they have a version 1? Oh, look, there is one. Okay, well,
hmm
I don't know what the calls are, and then maybe the tool that would go through, and I don't know what the approach would be to kind of actively interact with that, and like hopefully, reveal some maybe commonly named endpoint,
yeah, yeah,
URLs. I don't know. I don't know if there was a tool for that, but if you're aware of that at all.
yeah. No, I think I had that question at the meetup last week, talking about like open source things that can do that stuff. I'm not very familiar with it,
And
but
that's almost kind of similar to like if you're trying to,
yeah,
break the security of like a WordPress site or something, right? I mean, as
right,
there's sort of like the known WordPress things, but you know, sussing out some of the stuff that is should be there, but maybe isn't being used by the person who set up
right,
the WordPress site.
right.
What about now? It's
Um,
interesting they used an example of. You had something else?
No, I was gonna say I was gonna get to your next question.
Okay.
I'm just looking at your fifth question. I've not delved too deeply into the Tor hidden service, anything like that. So I think I'll kind of just defer that one. If you want to hit me up with that later, I'll have to do some digging on that. But
I actually did.
for,
I actually did try to set something up, and that's how I kind of looked into, like, if you wanted
okay.
to secure an API and you wanted your source code public, but you wanted your infrastructure hidden. There's no reason why you can't create
Oh,
an API and you can hide it behind a hidden service, and then
gotcha.
but then you can't, even if it was kind of security through obscurity and you're not revealing that onion address of how to get to it, you still wouldn't want the world to be like, anonymously hammering on this API. So there's a
Right,
mechanism within Tor to actually do kind of network level authentication between the Tor client and the Tor server. So
right.
I got that to work, but I just wanted to know if you could shed some light on that at all. But
No, yeah.
um
Unfortunately.
and then
Uh,
number 4, because it's interesting because you had example of a Flask code that was using the Flask web framework.
hmm Yep.
Um, Known common issues with Flask, like,
Um,
don't use
unfor-
Flask. I mean, that nice little flashy red message of like this, you know, this is don't
right.
use this in production.
Right, right. Yeah. I mean, Flask is really like lightweight for me just to set up quick little applications like that. Obviously, again, I'm not a developer. If you are, definitely use the one that is more secure. I'm just basically putting this together in my own little demo environment.
Oh, that wasn't a
Uh,
criticism at all. I'm just saying it's
no,
like,
that's what I
it's
mean.
such a
Yeah,
common thing that like I wonder like how
I'm
often
not
you've seen that, or like, that's such a knee jerk, thing, thing for people to do. And
right.
yet, yeah.
Yeah, like this. So that's again more diving into like the technical side of the development stuff, and like I know enough to put this stuff together just from like my software engineering days. But at the same time, like if I were developing an API, I'd learn everything about it and like the known common security issues. I'm not sure with Flask and best frameworks to use. Right now, it's like I said, because it's so lightweight and easy to demo. I'm just using that. So
Yeah, yeah.
um, yeah.
So, and also one additional thing, you mentioned something about Swagger inventory. I've never heard of
Yep.
it. So
Swagger.
that
Yep.
seems like that would be a way to kind of webilize a little documentation associated with that API. I mean, in a way,
Yep.
it's kind of like half the fun or a partial functionality of that Explorer website. At least you've got some kind of webilized thing that says, click here to, maybe like you buried in your documentation, internally, and click here to like see all the API crap that we have. And somebody clicks
Right.
that and up comes the Swagger inventory.
Yep. Yep. It makes like the security job a lot easier if companies have like public APIs disclosed like that and have it well documented, because then if there is an attack against a public API, that either I see or a security analyst sees, that's just all available. I don't have to make a phone call or ping anybody, because it's all there, and then I can
Uh-huh.
base it off of that. But um, yeah, as far as
So
I know, like
mhm.
Swagger's. Yeah, go ahead.
Well, I'm just saying it's like if you got the sample application, it's this Flask thing, right? Presents a little RESTful, API, whatever. Okay,
Hmm.
and you got some, endpoints, and you got your little, @ sign, what is it, like route statements, or here's my
Hmm.
little API endpoint,
Yep.
whatever. Is it that the Swagger tool, can you point it at your API or your Python code, and it'll suss those out, or you can put stuff in comments and sort of like if I just put a little notation in here about it, then I point the Swagger tool at it, kind of like Python documentation tools
Hmm.
will sort of key
Um,
in off of those triple accent graves in
I, as
comments.
far as I know, yeah, no, as far as I know, I don't think it can actively suss those out. It
Okay.
might be able to, but as far as I know, like that's just something that the developers will fill out themselves, and then if there's a way to like import that from like a JSON. I haven't played around with it too much, but because it's publicly available, like if you find a company like I had in the example that has it all published, you can see, um, however they have that architected, whether it's with the framework like Flask or something.
Okay.
Basically, somebody has to take that step to put it there. I don't think it can actively do that, but maybe it can. I'm not sure.
Sorry to ask so many
You're
random
good. a
API
lot of
questions, but
a
I was
lot of
literally listening
technical.
to
Yeah,
this. Yeah.
no worries, no worries.
Sorry, and I
Um,
didn't mean to be a buzzkill, man. I feel like, we were overloaded on this channel. People are trying to cram in here, and maybe I don't know, like half of them left. Sorry, sorry,
you're all
sorry.
right. Um,
Thank you.
any other? Yeah, of course. Any other questions? Okay, cool.
I just want to do yeah. Thanks a lot for the talk. Great talk, MSYooper.
Of course. Thank you so much for having.